Air. It couldn't be more common. All of us overlook it in our daily lives. What would you do, however, if this yielding thing suddenly loomed in the way like a huge wall of granite? When a train exceeds 300 kilometers per hour, it reaches the super high-speed zone, where air noise, pressure waves, and other phenomena involving air present scarcely imaginable challenges to ride comfort and to the environment alongside the railway tracks. To provide commercial operations running at 300 kilometers per hour, we had to overcome one by one these phenomena that formed a wall of air. In 1964, the Shinkansen line that linked Tokyo and Osaka in 4 hours became known to the world as the symbol of Japan's post-war recovery. After that, in 1981, the TGV entered commercial operations in France and took the world record with a speed of 260 kilometers per hour. But in March 1997, the new Shinkansen Series 500 train, Nozomi of JR West Japan, achieved 300 kilometers per hour in commercial operations, thus after 16 years forcing the TGV to share its solo claim to being the world's fastest train. Also, the Nozomi became an exclusive world beater by recording the fastest average speed between departure and arrival stations of 242.5 kilometers per hour. This is JR West Japan's Hakata Car Maintenance Center. Here you can see various types of Shinkansen train. When the Shinkansen was newly developed in 1964, the train that was in service was called the Series 0. With various improvements, this type is still in operation today. The nose became somewhat more pointed in the Series 100, which also included 2 linked double-decker cars. After improvements were made to the Series 100, it became possible to include 4 connected double-decker cars, and this became the Series 100N. In 1993, the Series 300 made its debut as the Nozomi, which entered high-speed commercial service at 270 kilometers per hour. Following this, there was progress towards a train able to operate at 300 kilometers per hour in commercial services. This became the new Shinkansen Series 500 train. The Series 500 was developed to provide with superior quality the high-speed transportation that is so essential to modern society. Our twin objectives in this mission were to offer excellent standards with regard to environmental issues and to give high-speed performance. This is the new Shinkansen train that, as it undergoes transfiguration, will carry on into the changing generations. The Series 500 train was designed to be faster, quieter, and more comfortable. Up to now, JR West Japan has been using Series 100N trains. We have been looking into the possibility of increasing the running speed of this Shinkansen to 275 kilometers per hour, but if we were to proceed by only improving the existing trains, it would be difficult to resolve the issue of noise alongside the railway tracks. At this point, using the high-speed experimental train Win 350, we started to investigate environmental considerations involved with speeding up the Shinkansen. In the process, the top speed recorded was 350.4 kilometers per hour. There are trains that, due to the compression of air when they enter tunnels at high speed, cause a loud explosive noise as they near the end of tunnels. Another typical problem is caused by changes in air pressure when two trains go past each other at high speed in tunnels. Not only has it become necessary to install tunnel entrance hoods like this at the head of tunnels, but for trains, we also have to try harder to deal with air at the design stage. To determine the nose design, various shapes of dummy nose were used in tunnel entry tests. With these test results, we made progress in the investigation of a new shape for trains. This led to the stretched, long nose design. At 15 meters, it is by far the longest nose that has been seen on any train. The driver's cab, which was fitted with glass curved in 3 dimensions, came to have a smooth, canopy-style design. Since it was also necessary to try and improve the aerodynamic performance of the body, the train cars were made with a round cross-section like that of aircraft. In this way, the width of the passenger cars has been retained, while the cross-sectional area has been reduced. Ultimately, shaped by various trial and error experiments, the type became a high-performance new train with a beautiful style. For a train that runs on electricity, a pantograph to collect power is an absolute necessity. However, if the speed of the train is raised, in the wake of the pantograph a disturbance in the air current known as the Kármán vortex can arise, and this can greatly increase the amount of wind noise. Up to now, pantographs on the Shinkansen have been fitted with covers to, as far as possible, weaken the force of the wind and reduce the amount of wind noise that is generated. From the beginning, measures against noise have been strictly enforced on the Shinkansen. Near residential areas especially, we have set up noise barriers and taken other measures to decrease noise. To save the view from the train windows, however, when speed has been raised another notch, even with our ingenuity, there has been a limit to what we could do. Thus, it has become necessary to develop a completely new type of pantograph. The section of the pantograph that directly receives and collects electricity causes lift during high-speed running. As a result, contact with the overhead wires becomes unstable. We explored designs that would ensure stable contact with the overhead wires and also reduce wind noise. Subsequently, suspension technology that is used for road vehicles eventually came to be applied in the upright that supports the pantograph. Performance of the pantograph was established after mounting prototypes on the Win 350 and carrying out a series of running tests for electricity collection. Then, when the new type of pantograph was perfected, it was a simple form that consisted of a wing-shaped collector head mounted on a supporting upright that had an elliptical cross-section. To achieve greater noise reduction, small projections were added. This idea owes much to the study of the special flight feathers of the owl, which enable it to silently flap its wings. This and other subtle devices were applied after testing in a wind tunnel. To suppress the wind noise of the pantograph itself, the cover fits only over the insulator. The whole arrangement is much smaller than hitherto, and this has brought about a corresponding reduction in the amount of noise. To provide a more comfortable journey, we have employed new technology in the bogies, which, properly speaking, form the foundation of the train cars. We carried out test runs to evaluate high-speed passenger comfort. Using this data, we focused on providing a comfortable ride. While making further improvements to the high-speed bolsterless bogie, to reduce rocking, we developed semi-active suspension that uses computer control. We fitted a damper between the bogie and the body of the train car that suppresses rocking of the car by controlling the damping force. When the rocking of the body tends to increase, the damper gets harder and provides firm support to the body. On the other hand, when the rocking tends to decrease, the damping becomes softer. Thus, the system provides the cushioning and stability that make for a comfortable ride. As well as this, to reduce weight, we have used brazed aluminium honeycomb panels throughout most of the body of the cars, including the sides and floor. These brazed aluminium honeycomb panels have excellent characteristics against noise. While they reduce weight, they also serve to make the inside of the train quieter. Also, to make the surface of the train smoother, in addition to reducing the differences in height between the window glass and the body, plug doors have been adopted. Things are also smoother on the roof. We've done without the cable heads for high voltage cable joints. Large protuberances have been avoided by using direct joints for high voltage cables. Wind resistance has been reduced by fitting external hoods between cars, and even in places where you would not look, including under the floor, we have made use of body mount structures. In this way, we finished the Series 500 train by blending the cream of advanced technology into a beautiful form. This was loaded on a special ship that was bound for the port of Hakata. After being loaded on special trailers at Hakata port and being transported from there late at night over normal roads, the train arrived at the Hakata Car Maintenance Center. Then, with everyone looking forward to the day when the train would enter regular service, the Series 500 train underwent repeated testing in over 420,000 kilometers of trial runs. The Series 500 driver's cab is designed to lessen the stress involved in high-speed running at 300 kilometers per hour. The cab has features that give consideration to the psychological comfort of the train crew. All of the indicator panels and controls for various functions of the train have their own special area, and the driver can read the information clearly from flat panel displays. The ordinary cars are designed to provide calm comfort. A cheerful shade of violet was selected as the keynote in the color scheme. In particular, we have paid attention to small details such as widening the central seat in the 3-seat rows by 30 millimeters. The green cars are finished in relaxing shades of beige. With soft, indirect lighting and sensitive attention to detail, we have provided all the comforts that first-class travel implies. For example, there are movable headrests and footrests to make the car environment comprehensively adjustable to the passenger. Also, every seat has its own reading lamp. We offer a more complete space for transportation. Other facilities include, in car number 11, a rest room that offers easy access to wheelchairs. Throughout the train, the aisles and floors have been made flat with minimal height differences. The washstands are hygienic and easy to use, while private phone booths allow quiet telephone conversations. Toilets are equipped with folding tables that are convenient for changing baby diapers. And we have provided the trains with multi-purpose rooms for occasions such as if passengers become unwell. Train crews from the drivers downwards have been thoroughly drilled and educated to ensure that passengers have a safe and comfortable journey. Meanwhile, on-board shops in cars 7 and 11 provide a welcoming change of atmosphere. The JR West Japan Shinkansen Series 500 train travels between Shin Osaka and Hakata at an average speed of 242.5 kilometers per hour, covering the distance in an amazing 2 hours and 17 minutes. This record-breaking time is the curtain raiser for a new millennium of railway travel. We have done this by gathering the best that the latest hard technology has to offer, while combining it with thorough attention to advances in softer areas such as the relation between people and the environment.
Densha 指定席ののぞみ503号博多行きです。この電車は電車指定席です。小倉博多間の自由席特急券ではご乗車になりませんので、お乗り戻しのないようにご注意ください。
信号70、閉じめて時刻よし。
信号70、閉じめて時刻よし。
Here, let's look for a while at the view from the driver's cabin and the scenery viewed from the train windows.
信号120。
信号120。
違いですよね。信号170。
信号170。
B 標石編成16両。
B 標石編成16両。
ブレーキよし。
信号30、ブレーキよし。
よし、平成16両。
平成16両。
16両停止位置。よし。
16両停止位置よし。
The Series 500 Nozomi rolls into Hakata Station right on time. After discharging its passengers at Hakata Station, the new Shinkansen Series 500 train moves on to the JR West Japan Shinkansen base at the Hakata Car Maintenance Center. Here, after finishing its run, the new Shinkansen Series 500 train passes along the work tracks, where the interior is neatly cleaned. Every part also undergoes inspection. After the train proceeds along the washing track and has the grime removed, it passes into the storage tracks. Here, the Shinkansen trains enjoy a well-earned rest until they are called for duty again. All this is only possible due to the passionate commitment and unceasing effort of a large number of people, from the experts who develop the technology to the staff who perform the work that keeps the trains running on the railways of Japan.